like to introduce you a TNA we have conducted within 2 periods here at University of Kaiserslautern, and maybe the topic is something similar to other things we have done in the range of joint research activities. So the TNA topic, and the name is called Cooperation in Virtual Manufacturing Research using VirCA. So this is the name, and it's also the topic of the whole TNA. It was a cooperation between University of Budapest and University of Kaiserslautern, and the initial scope was to test out the VirCA tool, which was initially developed in Budapest, to deploy the system to deploy the software at our systems, and to test out if it is possible to link two similar but also different virtual reality systems together with this tool. So that was the initial scope, and I think you will see more during the presentation. Today I have prepared 3 major topics for you. I'd like to start with some motivation. What was the initial target the TNA was facing on? I'd like to present you the working plan, and also give you some impressions on the TNA implementation in the end. The overall background for this TNA is mechanical engineering, as we and also our guests from University of Budapest are coming from this direction. So the question in the mechanical engineering for today's engineers is that there are highly complex and multi-domain interrelations when planning and when designing manufacturing systems. So you have to tackle with very detailed problems on workplace level, but you also have to tackle bigger problems, and you have to face bigger correlations on the factory side. And you have to see all these things together to find proper solution. And on the other hand, a lot of different people are involved in today's mechanical engineering solutions. So when you're trying to develop a production system, when you design a factory, not only the factory designer, but also some product responsible persons and a lot of other people are involved in this, in such a planning. And therefore, the working conditions in mechanical engineering is offering different challenges. On the first side, due to the involvement of different people, a lot of different points of view need to be integrated into one solution. Every involved person is trying to solve his own problems, and having a very special point of view on some very detailed aspects within the planning problem. This is also dealing with this different personal objectives. So, for instance, the guys dealing with logistics have to ensure a fluent material flow throughout the factory, whereas product responsible persons are more or less focused on the proper design and on the proper implementation of products. And in the end, also different know-hows and different experiences have to merge to merge together to create a holistic solution. But also challenges arise of that, because when different people come together and everyone tries to solve its own problems, it's very easy that people talk at cross purposes. But in the end, due to the fact that the problems in mechanical engineering and factory planning are very complex, so if you think of a complete layout plan for a factory, a lot of decisions need to be done. So problems are very, very complex, and you have to tackle these complexity. You have to involve all the several domains which are involved, and in the end, an isolated solution is not suitable to fit all these problems. So the problem solving must be a collaborative process. And this is one part of the motivation coming from the mechanical engineering point of view. And in this mechanical engineering domain, a lot of IT tools have been introduced to solve these problems. Maybe you know the digital factory, you know this approach that beginning from the product, from one single product to a complete factory, that all the planning should be tackled by digital tools, and the information exchange should happen and should work in a proper way. So digital tools are available, but for the point of virtual reality cooperation, they often lack in supportive features. So real collaboration within virtual reality is not ensured, it's not granted by these mechanical engineering IT solutions. So this is a problem of today's IT situation for mechanical engineers. But what is the proposed solution? The proposed solution is that researchers in the range of virtual reality develop their tools, develop their software systems, which ensure the connection between different virtual reality systems, so that multiple caves, for instance, are coupled together, and that spatially dislocated people can work together as if they were co-located. So this is the traditional research approach when you're looking at this field of research. But also out of this, different challenges appear. Different challenges, as sketched here in this slide, are coming from the specialized user groups. Often, the people who are developing such virtual reality tools are very deep into it, and they are used to handle the tools because they developed it. But in the end, users and developers, if you try to couple different virtual reality tools, users and developers are not always the same. For instance, in this TNA approach, we as host have had no experience in developing such systems. We have no insight into the VirCA programming, but we would like to be the user of the whole setup because we think we can create beneficial output in our specific domain, even without knowing the tool inside and even without knowing the problem. But as users and developers are not for this approach not the same group of persons, the knowledge about the systems, about the tools are differing. So we, for instance, we have no deeper insight into the systems. And in the end, the systems often, or they should be evaluated against an industrial-like use case. And maybe, and we have the feeling that often these industrial-like use cases are not that easy to be created from IT guys. So you have to merge the IT knowledge of the developer and the factory planning knowledge of, for instance, us as hosts together to create some industrial-like use cases and to evaluate if the proposed approach is working in the end. So summarizing these challenges, you can say that often academic software prototypes don't leave the lab. They stay in the lab where the developer is located, and therefore developers cannot gather that information and cannot gather that experience, how the software would behave at other systems and how other people who are not that deep into the programming can use the systems. The potential of these IT tools, of these academic prototypes, they have to be proved. They have to be evaluated within a larger group of partners coming from different points of view with different professional experiences. These collaborative virtual reality tools need to be deployed to multiple facilities because the initial collaborative aspect for sure can only be granted when different tools are merged together. So also here within this virtual reality research projects, isolated solutions are often not suitable. So in addition to the mechanical engineering approach, also this collaborative software development should be a collaborative process. And that was initially the basis on where our guests and we came together for this TNA. So our guests offered high IT experiences. They offered the knowledge about the software itself, and we could offer some knowledge about what to do with the software and which use cases to work and to prepare for the software. So the proposed idea for the TNA was to connect virtual reality visualization tools to share, so as you see in this slide, to connect the Budapest cave and the Kaiserslautern cave together to realize shared visualization of production scenarios as the use case. And within this factory planning production scenario approach, it was needed to change and adapt the virtual scene from both positions, from both locations, to say in the end, the picture is worth 1,000 words, to introduce production scenarios to both partners independent from their location. So that was the overall idea on which the transnational access was based initially. And this in mind, we created a working plan. We created a working plan which was quite detailed and which requested some effort from both sides, from our guests and from us as hosts as well. In detail, the working plan looked like that the user, which was Peter Gellenberg from the Budapest University of Technology, he provided software know-how because he and his team, they are software specialists. They developed the VirCA software based on their systems, and they also had first experiences in this distance collaboration thing at all. So they knew the complete implementation for this collaboration things. And they also provided a cave, which was the counterpart to the University of Kaiserslautern cave. So in the end, they provided the software know-how and they requested the counterpart to test out if their software, if their programming and the ideas behind can work on another installation, on another virtual reality setup that was not integrated into the whole development process of the software tool. So we as host, we delivered on the one side use case, some kind of use case specialist to validate the distance collaboration approach against the industrial-like use case. Therefore, our mechanical engineering expertise served as major input. And we also provided a cave to make the to serve as counterpart to make the software implementable at University of Kaiserslautern. So this was the host-user relationship, and out of this, the following working plan was developed. The VirCA instance first needs to be prepared. because due to the differences between the virtual reality system at Budapest and the virtual reality system at Kaiserslautern, the software needs to be extended to capture distributed rendering. So at Budapest, only one server is providing the rendered images to the cave, whereas in Kaiserslautern we are running visualization clusters where each projector is provided by one single computer. So therefore, the first thing that was done in front of the transnational access was the preparation and the extension of the VirCA system to be able to capture all hardware systems in our cave. Next thing was the deployment of VirCA at our systems. This was partially done before the TNA, but the major things have been done during the TNA. And the third part was test and fine-tuning the installation. And maybe you know, when you're trying to install a new software tool at your system, a new prototype that is nothing that runs out of the box, this testing and fine-tuning took quite a lot of time to figure out how the tool is running, how our systems behave, and to merge the hardware and the software parts. The next thing was to test the capabilities in the range of factory planning. Therefore, we introduced a use case and tested different setups, tested different features and functionalities within this factory planning use case. The implementation of our tracking system was also a new thing to the software, and this tracking implementation was also done during the TNA. And in the end, we developed a publishable demo. So that was the working plan, and we executed this working plan. Needs to be or have been done during the test out. So the first period started with the deployment of VirCA at our cave system and testing and fine-tuning the installation. And this was about a week workshop to test out if the extended software is able to run, and to bring the academic prototype out of the original developers lab. In the second period, we start with this running setup, and we tested out the capabilities in the range of factory planning. So we implemented on the one side the ART tracking system, and on the other side we implemented the use case, the modeling and the interaction capabilities. So the development of a publishable demo of some the concentration of all the tests we did towards a very focused demo that showed all the capabilities, that shows all the interaction within a very compressed time frame, was in the end the output, or the major output of the TNA. And I think this use case, this typical setup you have seen, I think, during the last General Assembly or during the Infocom conference, where we had this live demo running without any bigger problems, without any without any difficulties, and showing quite a wide range of researchers what we did, showing quite a wide range of researchers how we extended this software tool, how we deployed it to a laboratory that was not involved in the development of the system itself, and in the end to show how we can bring different planning participants together to work in one virtual environment, and also or even to connect physical objects like machines or robots to this interactive setup. Concluding, the dissemination for the TNA went in a range that we had joint demos and papers at the CogInfocom conference. we had some joint demonstration at the Visionair General Assembly, and we're right at the moment submitting or under submission for a joint international journal publication to bring the results and to bring the whole process to the research community in the end.
I would like to ask a short question about your own impression with VirCA and the rapidity to develop the connection in Kaiserslautern. Was it complex to make this setup in Kaiserslautern? And what is the openness of a plugin or of a system you developed for that? So it has been created for a single demonstration? And if we want to apply another use case than the demonstration you created, what will be the effort to make the adoption?
The implementation of the software at our system was, I think, not that complex. I think for sure the people who from Budapest who have been involved in development, with their help, it was quite a fluent process to install the program. I think they have done a lot of preparation stuff to make the software deployable to our distributed rendering system. For that, I have no idea how much effort it was. The effort to implement the system here was more or less testing out and fine-tuning the configuration. So it was, I think, if you know the process, and I think also now they could gather some experience in deploying their tools to foreign systems. I think with this experience and virtual reality tool systems, which are quite kind of similar, they can do some deployment within, let's say, 2 to 4 days. So it's for sure nothing you just press the button and it's installing and everything's perfect. But I think it's not, deployment is not that complex. The use case we developed was, or developing the use cases in our range was in the end modeling factory and transferring the factory model into the proper file format. So it's as long as you limit the use case to such kind of interactions and to such kind of use cases, the system is quite open. So it's possible to implement more or less every kind of digital model as long as you can transfer it into the right data format. But it was not a problem. So I think it's quite open. Considering some dynamic or flexible things, that's something we have not done in developing the use case. I think if you would like to do this, it would be more effort to learn and to understand the system. But as long as it's only implementation of existing or of modeled or existing three-dimensional models into the system to establish such use case, I think it's quite easy and quite open.
What I remember, just to follow my initial question, is when you organize a specific cell in the VirCA system, you use a graph where you put the plugin of the component of your environment, and then you just connect them together. And my question was related about the number of links you can create between the bricks. And is it possible to define a very complex system with a lot of potential connection? Unless you have something which is quite fixed for real usage.
I don't know the limitations of the system. We have done tests with quite complex models with up to 4 connected partners. And there it was never a problem regarding bandwidth or regarding any limitations. So we had quite no problems. So we did no tests in some delay time. But I had the feeling that even without any fiber networks or so, that the connection was always running very fluent. So it was, from my point of view, we didn't reach the limit of the system.